Hi, Mr. Slusher again from the QRC. Do you realize how lucky you are? You have earned an appointment to the United States Air Force Academy. You are one of very few people. For every one of you, there's probably 5 folks out there attending community college or slinging hamburgers somewhere that didn't get the appointment that you got. So take advantage of it. Don't waste it. Alright. Okay, our problem for today is homework problem number 7 from section 8.5. Okay, in this problem we have a boat in the water and there's an anchor hanging off of a chain. The anchor weighs 150 pounds, the chain weighs 2 pounds per foot. Now what we're going to do is we're going to try to figure out how much work it takes to lift that chain and anchor up to the surface level of the water. Okay, so you probably noticed my numbers are a little different than yours. Did that so that you get to work your own problem, but it's all the same. Works out the same way. So, I have a chain and I have an anchor and I've got to lift those up to the surface of the water. Okay, if we're looking for work, remember the formula for work? It's work is force times distance. So if I could just figure out how far I'm lifting how much weight, I've got my answer. Okay, so let's do that. Okay, so what am I lifting? I'm lifting, let's find out the force first and then we'll worry about the distance. Okay, so for my force, I've got a 150 pound anchor that I'm pulling on. Okay, I've got 150 pounds. And now I've got this chain here that I'm concerned about. Okay, so let's just call this distance right here y. Okay, if I've pulled up y amount of chain and I want to pull up this much more, we'll call it delta y. Okay, I need to move I want to see an infinitesimal little slice of work, as it were. Okay, so to do that, I'm going to have to move just a tiny little bit, and I'm lifting the anchor plus a certain amount of chain. How much chain? That's the big question. Let's figure that out. Okay, if I've lifted y already, how much is left? Well, obviously it's 25 minus y. So that is the amount of chain that I have left to lift. So I've got my anchor plus this amount of chain, which is 25 minus y. Okay, that chain weighs 2 pounds per foot. So if I've got 25 minus y feet of chain, then I multiply it by 2 to get the force. Okay, those are the only 2 forces that I have that I'm doing work on. I'm working on the anchor and the chain. Okay, so what about distance? We need a distance so we can define work. We have our force, and so our work is equal to 150 plus 25 minus y times 2. Now my distance that I'm moving delta y. There you have it. Delta y. Okay, so we can do a little bit of algebra here, simplify this thing, make it easy to integrate. So I've got 150 plus 50 minus 2y all times delta y. So that is the amount of work to move it just a little delta y distance. Okay, so now I not only want to know how much work it took to move it that little delta y distance, but I want to know how much work it took to move it the entire 25 feet. So to do that, I'm going to have to add up all those little pieces. So we can use our friend the sigma here. Let's do some more algebra. Let's go 200 minus 2y times delta y. Okay, now I want a really accurate answer here, so I'm going to take the limit as delta y approaches 0. Okay, and we can solve this using an integral. Integration techniques, quite simple. Okay, limits of integration. I've got to start thinking about that now too. How far am I going to move this thing? Well, obviously, I'm moving it. If I was starting here, I would be moving none, 0 distance. And by the time I've moved it clear to the top, I've moved it 25 feet. So, those are my limits of integration. 0 to 25. Okay, let's work this integral. Let's go ahead and make a little room up here on the top, shall we? Got all this. Okay, so I'll rewrite my integral 0 to 25 of 200 minus 2y times dy. Simple integral. 200y minus y squared. And we're going to evaluate it from 0 to 25. We can do this, the old fundamental theorem of calculus here, 25 into here, we've got, looks like about 5,000 minus 25 squared is 625. Okay, we've got all that. Minus, now we're going to put 0 in here, and obviously that is just 0. So what I'm left with is 4,375 foot-pounds of work. Okay, good units because I've got feet and I'm lifting at pounds. And that looks like a good answer. So let's look at what we did here. We took the weight of the anchor, which we had to lift 25 feet. We took the amount of chain, which was varying as we lifted it. Remember, the amount of chain I'm pulling is varying. It's getting less and less as I'm retrieving that chain in. And we accounted for that in this formula. Accounted for all of our weights, all of our distance, and we found an answer. Okay, very good. Now it's your turn.